Hi folks, you are already familiar with the LTSpice GUI and toolbox. In last couple of episodes, we have used the nMOS and PMOS together as CMOS for digital electronics applications. In today's episode, we will explore the transfer characteristics, that is ID versus VGS curves, using the same monolithic nMOSFET that we have used earlier. Then we will explore its drain characteristics, that is ID versus VDS curves. In both the cases, we will be using DC sweep in DC analysis. So stay tuned, stay focused. Hey guys, welcome back. Today we'll be analyzing the different characteristics, that is transfer characteristics and drain characteristics of the MOSFETs, specifically the nMOSFET, which we have already used in all the previous episodes for construction of the CMOS circuits. That means today's episode will be on the analog analysis of a MOSFET device, specifically a nMOS device. For last couple of episodes, we are using the GUI and not using the keyboard shortcuts. However, we have crossed multiple episodes and I think by now on you are ready to use the keyboard shortcuts. For a designer, these keyboard shortcuts are very much time saving, and one thing I would like to emphasize here, which keyboard key is used for the shortcut. It's very simple. Generally what you are doing, right? Usually the initial letter is there. There are little changes at some point, and here on the screen you can see that I have listed some of the frequently used keyboard shortcut. At left side we have the component or whatever action we are doing. I must write it as action, and right hand column I have keyboard shortcut. So first thing is that often we insert register, right? So the register will be inserted by the keyboard key once you hit R. And why it is showing smaller? Because you have hidden the key directly and you have not used any other keys. Similarly, for capacitor, we will hit the keyboard key C. Next comes the inductor. You can guess what will be. This is L. For voltage, that means once we want to insert any blank voltage source, later we can configure whether it is AC, DC or something else. For that, we will be using the keyboard key V. And you can see all of them are in small. That means you are hitting all these keys without touching any other key. Now comes the wiring. Wiring means when you are connecting wires, right? For that, you will be using the small w. That is, you are hitting the W key without touching any other key. For ground, we will be using G, and it's small g. That means we are not touching any other key of the keyboard. Next is select and move component. That means whenever we are selecting any components and changing its position or changing the name of a component, we can use this key. To move something, that means select and move, we use M. And you can see it is small m. That means from the keyboard, we will hit the M key without touching any other key. Now, deleting any wiring or any component, or we want to remove any other thing like ground. Say, what keyboard key we will be using? We will be using the delete key. Why I have to write? Because delete has a ASCII code which is non-printable. So if I hit delete, right, nothing will come here. So these are the shortcuts. So these are the component or action and the keyboard shortcut. For resistor, we will be using small r. Capacitor, we will be using small c. Inductor, we will be using L. Voltage, we will be using B. Wiring, we will be using W. For ground, we will be using G. For select and move, that means move is the main thing, right? M. We'll be using M, and delete any wiring or component, we'll be using the delete. So this delete comes with a scissor symbol like this. Please remember that. Here all this keyboard shortcut we will be using further episode, that means this episode and the upcoming episodes. So you can assume that you are going in a much more pro level of using the LTSpice. However, in narration, I will be saying that I am hitting the R or hitting the C from the keyboard, so you can understand. You have to follow this. So we are done here. Now let's move on to the circuitry. Let me now click on the LTSpice icon, and the LTSpice window has opened up. So we will go for a new file. First, I have to save this file with a name. I go to File, then Save As, and here I type nMOS characteristics and I hit Enter. For this circuit, we will be using the same MOSFET, that is nMOS4, that we have already used in the previous episodes where we have constructed the CMOS, and I'll click and place. This is a monolithic MOSFET which we have used, and we will be using the same dimensions that we have used in the earlier episode, so that you can know about the characteristics of the MOSFETs that we have been using. So let me click and place it and right click to vanish it. I zoom out a bit because the circuit needs to be constructed in a very sleek fashion. So I'll hit R from the keyboard. The resistor comes in. Then I hit Ctrl plus R to rotate it. So I'll place one resistor here at the gate input and one here which is connected to the drain. Now I will hit V from the keyboard for the voltage source, and you can see it has come up. So let me place the input voltage here, and here somewhere I will place the drain voltage. So let me right click and vanish it. Now I will hit W from the keyboard. You can see automatically the wiring comes up, and let me do the wirings. First is done. Let me connect to this gate. Let me go above, click here, go right, and click here. I click here, go rightwards, come down up to this point. I click here, come all the way along, and then I click here. Now I will connect this source to ground. Now I click here and connect this to the ground. Now from the keyboard I will hit G. The ground symbol comes here. I'll click here. I right click to vanish it. Next I will hit the W from the keyboard. So the wiring comes up. I'll click here and click it. So our wiring is finished. Let me go and click save. Now I'll do one thing. I'll click here, rename it as RG. I rename it as RD, and I'll name this as VGS, and I rename this as VDS. Now the circuit wiring is completed. I'll do the value assignments starting with the nMOS. I right click here and I'll put the values here. So the length will be 20 micro and the width will be 100 micro. If you remember from the CMOS episodes, we have used these values particularly for the nMOS. Whatever number of nMOS we have used, I have used these values. I'll click OK to save it inside the device, and then I'll click save to save the file. Now this RG will be valued of 330 ohms and RD will be 33 ohms. So here I'll assign this value as 0 because we will be using the DC sweep, and initially we'll keep the voltages 0, and during the DC sweep options we will vary the voltages. So let me click OK, and this voltage also I'll giving 0. So both the voltages have been assigned. Let me click to the save icon, and here you can see the circuit is complete. Ground is okay, and I think everything is okay. This is a very simple circuit. Now we'll do the voltage variation through the DC sweep. Let me click on the spice directive to insert the spice.dc command. I'll click OK here, put it, and I'll right click the AC, assign the values. For transfer characteristics, that means ID, VGS curves for various VDS, the first source will be the VGS. So I type VGS. Type of the sweep is linear. Start value will be 0, end value or the stop value will be 5, and the increment will be 1. The second source, that will be VDS. The start value is 0, the stop value is 15, and the increment value or the step is 1. So for transfer characteristics, the first source is VGS. We are giving the sweep linear, and for these ID VGS curves, the VDS is linear and start at 0, stop value is 15, and it will increment with 1. So I'll click OK. So the DC sweep analysis is placed here. Let me click save and I'll hit the run to run the simulation. Now for this particular ID versus VGS curve, I'll have to click the current which is going through the drain, that is RD. So here in this graph, you can see we have varied the VGS from 0 to 5. So let me select the pencil from my on-screen marker. So here you can see we have chosen the RD, that means to which the current is going into the drain, to this current. And here in this x-axis, we have 0 to 5 variation, which is done for the VGS. So this axis is VGS and this is ID. So we have the transfer characteristics, and you can see here we have 5 lines, 1, 2, 3, 4 and 5. These 5 lines are for the various values of the VDS. So our transfer characteristics is done. Now with the same circuit, we'll do the drain characteristics. Let me click and close it. Let me click and enlarge it. Now I will right click here and this opens up. So what I will do, I will not delete this one. I'll click edit text directly. Here it is showing as SPICE directive. We will do a commenting off, and once we comment it and click OK, it will become blue. You can see this has become blue and this is now a comment. This is no longer a SPICE directive. How? I can show you. I go to the view, then SPICE netlist, and here you can see this line is starting with a star. Now here I'll insert a SPICE directive .bc. I'll click OK and I'll place it here. Now I'll right click and start assigning the voltage values. The voltage values for the drain characteristics, we will change the first and second source that we have used earlier. So here the first source becomes VDS, type of sweep linear, start value is 0, top value is 15 and increment value is 1. You can choose a smaller increment voltage. Since I am showing you a example, I have given 1 so that the simulation ends quickly. If you decrease this time step, the simulation will take a little bit longer time. That's all. Now the second source will be here, VGS, type of sweep is linear, start value is 0, top value is 5 and increment value or the step is 1. So you can see the first source is VDS for the DC sweep, second source is VGS. So I'll click OK. Now I'll click save and I'll show you by view netlist. By this SPICE netlist, you can see that the first one DC sweep that we have used earlier is now commented and the latest one is now acting as the DC sweep. We are confirmed here. Let me click and close it. Let me click to fit to screen. You can see now it is fitted, and at this point I'll hit save here. I'll click run here. So the simulation comes here and let me show you the view SPICE output log, and you can see there is no error. This is a very simple circuit, that's why I have not shown in the earlier case. However, for you must check the SPICE log every time that you are simulating a circuit, so that if a mistake has been done by you, it will be pointed out this particular log by an error or warning message. So let me click and close it. Now, while analyzing the drain characteristics, that means ID and VDS for various VGS, again I will go up to the resistor RD and click here to get the curves. Let me bring my marker pen. You can see the voltage varies from 0 up to 14 volt. That means this is a variation of VDS, because we have varied the VGS from 0 to 5 volt and VDS I have varied from 0 to 15 volt. For that we have the drain characteristics. This is a well-known characteristic, so I do not need to explain this to you. You already know this, I am assuming, because this is the curve that you generally read in the textbook with explanation for different regions. And Here, since the current we have measured through RD, right? So this axis is ID, and this axis, x-axis, is VDS. So we get a ID versus VDS curve here, and these values for which we are getting different curves are coming from the variation in the VGS. That means we have 5 voltages here. We have 1, 2, 3, 4, 5. So we have 5 variation voltages for the VGS, and for that we have ID for different values of VDS. So let me clear the screen. So now we have done simulation of both the characteristics. That means the transfer characteristics as well as the drain characteristics. The problem is you cannot run both the characteristics at the same go, because there are 2 different sweeps, and in these 2 different sweeps we have exchanged the position of VGS and VDS. You can see here it is VDS and here it is VGS. So we have to do 2 simulation runs to see 2 different curves. And common thing is that we are always checking the current through the RD and not the current through RG. We are concerned about the current through RD. First, we get a variation of VGS with ID here, which is going through it. And in the second one, we see the variation of VDS versus the ID here. Both curves now you have to this simulation. Let me clear the markings, and I can say we are done here. That's all, folks. Thank you very much for watching up to this point, and don't forget to like, share and subscribe. In case you have some dislikes, put that as in words in the comment section down below. And bye for today.